All right, welcome to this explainer on the future of transportation. Let's just dive right into this because we are standing on the edge of a massive, massive revolution in how we move. Today, we're going to journey through the layered ecosystem of tomorrow's mobility. And look, we aren't just talking about a single cool new gadget here. We are going to explore a total top-to-bottom transformation. We'll start at the micro scale, literally your very own front door and neighborhood, then move out to the personal vehicles in your driveway, expand into high-speed regional travel, and finally, soar all the way up to the macro scale of global aviation. But to really understand why this revolution is so absolutely urgent, we have to look at this number right here, 200. Think about that for a second. The average person in the US and the EU spends over 200 hours a year just commuting. That is a massive chunk of our lives spent just sitting in traffic. But what's truly alarming about this massive volume of daily commuting is the environmental cost. All that driving contributes heavily to the fact that transportation has actually replaced electric power generation as our top source of CO2 emissions. So how on earth do we fix a problem that's this deeply ingrained in our daily lives? Well, let's start with Section 1, rethinking the neighborhood at the micro scale. To solve a massive problem like this, we actually don't start with sci-fi solutions like flying cars. We start by fundamentally redesigning our own neighborhoods. And that brings us to a really brilliant concept developed by Professor Carlos Marino back in 2016. It's called the 15-minute city. Essentially, it's an urban model where all your essential social, economic, and cultural services, so your shops, schools, workplaces, entertainment, are all less than a 15-minute walk or bike ride. Instead of dedicating something crazy like 66% of our public space to cars, which Marino actually observed in cities like Paris, this model brings the essentials right to the suburbs. It essentially replaces heavy, polluting car traffic with active green transit. And the ripple effect of this kind of hyper-proximity is just huge. For one, it saves 460 metric tons of carbon for every 100 people who switch to biking. It also cools down urban heat islands by replacing hot concrete with green canopies. Financially, it's a game changer. It saves low-income families up to $14,500 a year just by switching to transit. It even mitigates deep-rooted inequalities in formerly redlined neighborhoods by introducing cooling green spaces and much better transit options. But hey, even in a perfectly walkable 15-minute neighborhood, we still need physical goods delivered to our homes, right? And that brings us to the incredibly costly, heavily congested nightmare known as the last mile of logistics. To beat that traffic, autonomous drones are now stepping in to handle this final leg of delivery. Because these drones completely bypass road networks, delivery times are getting slashed by 30 to 50%. And out in rural areas, because drones can travel in a straight line instead of navigating winding country roads, they're actually 50% faster than traditional delivery vans. Plus, they're electric, which drastically cuts down on fuel consumption. And this isn't just some prototype concept, guys. Retail giant Walmart alone has already completed over 150,000 drone deliveries, often in under 30 minutes. We're looking at a rapidly growing $10.47 billion market that is quite literally taking delivery vans off our local streets. Now let's shift gears to Section 2, the smart, circular car at the personal scale. Look, there are always going to be times when we absolutely have to drive our own personal vehicles. But the very way we build those vehicles, that is totally transforming. Historically, the auto industry has relied on a linear economy. That's a super wasteful take, make, dispose approach that depletes finite resources, like rare earth metals, and pumps out high emissions. But now, we're shifting toward a circular economy. This means we're designing vehicles for longevity and resource efficiency, heavily relying on recycling and remanufacturing end-of-life components. The ultimate goal here is to essentially eliminate manufacturing waste and create a true closed-loop system for the cars of the future. And once those sustainable circular cars are built, they aren't just going to be isolated metal boxes on the road. They will be hyper-connected using 6G vehicle-to-everything, or V2X, networks. And honestly, this is where the tech gets truly mind-bending. You see, V2X has steadily evolved over time. We started with basic Wi-Fi-like communications, known as DSRC, back around 2010, and we've moved all the way up through the advanced 5G networks we use today. But as we push toward fully autonomous driving, 5G just isn't going to cut it. We need hyper-fast, ultra-reliable sub-millisecond data exchange to ensure those driverless cars don't, well, crash. And that is exactly what 6G is stepping in to support. A 6G V2X system is incredibly complex behind the scenes. It integrates things like quantum computing for real-time route optimization, blockchain to prevent data hacking, and terahertz networks to process massive amounts of sensory data. All of this is working together in a fraction of a second, just to let an autonomous car safely negotiate a blind intersection. Because of this massive technological leap, 6G V2X is going to enable features that sound straight out of sci-fi. We're going to see tactile communication, which allows for real-time haptic feedback for remote driving. There is even real research going into brain-vehicle interfacing, where a driver's actions can be predicted, or a vehicle can actually be controlled by human thought, which, by the way, could be absolutely revolutionary for drivers with disabilities. We'll also see programmable environments using intelligent reflecting surfaces. Essentially, these are smart materials placed on buildings at intersections that can bounce wireless signals around blind corners, completely eliminating blind spots for autonomous cars. All right, moving on to Section 3, high-speed ground transit at the regional scale. Zooming out from personal vehicles, let's compare two high-speed heavyweights that are going to define how we travel seamlessly between cities. On one side, we have high-speed rail, or HSR. This uses proven steel wheel-on-rail technology. It's electric, aerodynamically advanced, and it operates super reliably at speeds up to 400 kilometers per hour. On the other side, we have the much-talked-about Hyperloop. This concept proposes shooting magnetic pods through low-pressure vacuum tubes, which virtually eliminates air resistance. The Hyperloop promises blistering, near-supersonic theoretical speeds of over 1,200 kilometers per hour. But before we all rush out to buy our vacuum tube tickets, we do have to look at the reality on the ground today. High-speed rail is the practical, scalable, and fully proven solution that is already transforming global transportation right now. The Hyperloop, while incredibly exciting, still faces some massive hurdles. Acquiring the land, passing rigorous safety approvals, and keeping costs down mean that commercial Hyperloop systems are still years away. It's really the technology of the next generation, whereas high-speed rail is the technology of right now. Okay, final section, electrifying the skies at the macro scale. So how do we actually decarbonize the single most energy-intensive way humans travel? Well, the answer lies in the push for all-electric aircraft. The ultimate goal is to entirely replace hydraulic systems and traditional fossil fuel-burning propulsion with electrochemical energy units. This is the next great frontier in aviation. However, it's currently severely hindered by two main factors. First, battery energy density, because batteries are super heavy and just don't pack enough punch for long flights yet compared to jet fuel. And second, thermal management, which basically means figuring out how to keep those massive electrical systems from completely overheating. But despite those massive hurdles, the industry has laid out an incredibly ambitious timeline here. By 2030, the expectation is to have fully electric short-haul and regional flights up and running. By 2035, as we need to travel further, hydrogen electric powertrains will step in for mid-range flights. By 2040, we anticipate viable large electric aircraft capable of carrying over 100 passengers. And all of this builds toward one massive industry-wide goal, a completely net zero emissions global aviation industry by the year 2050. And guys, this isn't just theory on a whiteboard. Real pioneers are building this future today. Vertical Aerospace is already testing an urban air taxi designed for quick 11-minute hops. For regional travel, the Eviation Alice and the Heart ES30 are bringing electric and hybrid options to life. And on the largest scale, Airbus's Zero E concept relies on hydrogen fuel cells, which is wild because it leaves absolutely nothing behind but water vapor. But here's the catch. Inventing this amazing tech is really only half the battle. The other, arguably much more difficult half, is getting it legally and safely integrated into our national airspace. And right now, aviation authorities are scrambling just to catch up. A recent U.S. Government Accountability Office report highlighted a massive bottleneck here. Currently, the FAA is forced to evaluate these novel electric designs on a really slow, case-by-case basis. Why? Because they lack standardized rules for this new tech. And actually, more concerningly, they face severe staff skill gaps. They simply do not have enough engineers with dedicated expertise in electric and hydrogen propulsion. The regulatory body literally has to modernize just as fast as the aircraft manufacturers themselves. So for this to actually scale up, the FAA needs to ditch the case-by-case scramble and establish dedicated, standardized airworthiness regulations. Furthermore, our airports are going to need a total overhaul to include high-voltage charging infrastructure. And finally, air traffic controllers need concrete data on how a quiet, electric, vertical takeoff air taxi is going to safely mix into the exact same airspace as a massive, conventional Boeing 777 on final approach. And that brings us to our conclusion, the layered ecosystem of mobility. Because really, the future of transportation isn't some single silver bullet. It is this deeply layered ecosystem spanning everything from walking in a 15-minute neighborhood to taking hydrogen-powered global flights. So, as these massive technological and structural shifts take hold all around you